Hi, let's take a look at some problems in section 1.6, some additional problems. Let's start by solving this third-degree polynomial equation using the factoring in the zero product principle. The first thing we want to do whenever we're using factoring is to gather all of the terms on one side of the equation in descending exponent order and get a 0 on the other side of the equation. So I'm going to subtract 18y squared and 4y from both sides of the equation. And that leaves 9y cubed minus 18y squared minus 4y plus 8 on the left and 0 on the right side of the equation. Now I'm going to factor by grouping. So I'm going to find the greatest common factor to these first two terms, and that happens to be 9y squared. If I multiply 9y squared by y, I'll get 9y cubed, which is my first term. If I multiply 9y squared by negative 2, I get negative 18y squared, which is my second term. Now, if what I'm doing is going to work, I need to obtain y minus 2 as a factor when I extract the greatest common factor from these two terms. So what do I need to multiply y by to get negative 4y? That would be negative 4. So I need a negative 4 in this position. Now if negative 4 times negative 2 gives me this positive 8, then this factoring process is going to be successful. The key is that these two factors that I'm underlining in blue have to be identical in order for this process to work. So they need to be identical, and when I multiply this all out using the distributive property, I have to obtain each of the four terms that I begin with. So this process is called factoring by grouping. So I notice that my common factor is y minus 2. Notice how that appears as a factor in first position and in second position. In first position, y minus 2 was multiplied by 9y squared. In second position, y minus 2 was multiplied by negative 4. That's what my factorization looks like. Now, I notice that this expression, 9y squared minus 4, is a difference of two perfect squares. So I can actually factor that further. So 9y squared minus 4 factors into 3y minus 2 times 3y plus 2. And now I'm just recopying y minus 2. So each of these factors, using the zero product principle, each of these factors gets set equal to 0. So 3y minus 2 is 0. In order for this to be true, this is the zero product principle. Or 3y plus 2 is 0. Or y minus 2 is 0. So those are the three equations that I need to solve. Let's solve this first equation by adding 2 to both sides of the equation. When we do that, we obtain 3y equals 3. And then let's divide, 3y equals 2. You were probably wondering what I was doing. I was making a mistake is what I was doing. That looks better. And we're going to divide both the left and the right side by 3 in order to isolate that y. So y equals 2/3, or let's subtract 2 from both sides here. So 3y equals -2. Now let's divide both sides of this equation by 3. So that tells me y also can equal -2/3, and this original equation will be true. Here let's add 2 to both sides, and we find out that the third solution for our equation is y equal to 2. So my solution set is the set containing 2/3, -2/3, and 2. In the next problem, we want to solve this by making an appropriate substitution. So as you look at this equation, notice that I can use any letter other than the letter that is already in the equation. So the equation has a variable of x, so I can use any letter but x as my letter of substitution. So I like to use the letter U. A lot of times the book will use a T. I don't like to use the letter T because it looks like a plus sign. So for that reason, you can use any letter though except for the letter X. So we're going to let U equal x squared minus 2x. And what we're going to do is we're going to rewrite this equation, and wherever we see x squared minus 2x, we're going to replace that with a u. So this becomes u squared minus 11u plus 24. So we temporarily make this look like a much easier and more familiar problem. And we can actually solve this by factoring. U minus 8 times u minus 3 equals 0, which means either u minus 8 is 0 or u minus 3 is 0. Well, that means u is 8. If I add 8 to both sides of this first equation, I'll obtain u equals to 8, or either u equals to 3. Now, I always want to make sure I wind up back in my original variable, which was x. So I'm actually going to replace the u's now with x squared minus 2x, because that's what I said they were equal to. So x squared minus 2x equals 8, or x squared minus 2x equals 3. So let's get a 0 on the left side or the right side of both of these equations. In the first case, I'm going to subtract 8 from both sides. In the second case, I'm going to subtract 3 from both sides of the equation. And I wind up with 2 quadratic equations. So this factors into x minus 4 times x plus 2 equals 0. And this factors into x minus 3 times x plus 1 equals 0. So either x minus 4 is 0 or x plus 2 is 0 or x minus 3 is 0 or x plus 1 is 0. So those are the 4 possibilities. So this means if I add 4 to both sides, x equals 4. Here if I add negative 2 to both sides, x equals negative 2. Here if I add 3 to both sides, I find that x equals 3. Here adding negative 1 to both sides of the equation, I find x equals negative 1. And here's my solution set. And I kind of mixed up the order of the solution set to emphasize the fact that in a set, the order of the elements of a set do not matter. So as long as I've got these 4 numbers as part of my set, it does not matter what order those numbers are in. All right, now let's look at let's end this by looking at 3 of the absolute value equations. One of the first things I should do in an absolute value equation is make sure that I isolate the absolute value before I try to rewrite the equation without absolute value. So in this case, I'm going to subtract 2 from both sides as my first step. So 7 times the absolute value of 3x is equal to 14. Notice the absolute value is still not isolated because it's being multiplied by a 7. So in this next step, I'm going to divide the left and the right side of the equation by 7 in order to isolate that absolute value. So the absolute value of 3x is equal to 2. So what this does is it gives me 2 equations. So an absolute value equation in most cases is a way to write 2 equations by writing 1 equation. So this is actually 2 equations written as 1. So either 3x is negative 2 or 3x is 2. So that's the property that was discussed in the PowerPoint and in your text, that as long as this is a positive number, either what's inside of the absolute value equals the negative or opposite of that number, or what was inside of the absolute value bars equals that number. Dividing both sides by 3, x is negative 2/3, or x is 2/3. And in this case, the 2 values are opposites, but depending on the nature of the equation, these 2 numbers do not have to be opposites of one another. So my solution set is the set containing negative 2/3 and positive 2/3. So the thing you want to be careful about is thinking that these solutions have to always be opposites. They do not have to be. It depends on the nature and structure of the equation that we were solving. So you could possibly get something like 2/3 is one solution and 5 is the other. So the two results do not have to be opposites as they are in this case. Okay, now let's solve another absolute value equation. Absolute value of x plus 1 plus 6 equals 2. Remember, the first step is to always isolate the absolute value. So in this case, I do that by subtracting 6 from both sides of the equation. And I wind up with absolute value of x plus 1 equals -4. And I stop right there. The reason I stop here is because absolute value is always positive or 0. So if I get an equation that's saying absolute value of some expression is negative, that will never be true. So this original equation has no solutions. So the solution set is the empty set. Solution set is the empty set, which can either be written as a set of empty braces or as 0 with a slash through it. You don't, however, use the braces and put 0 with a slash through it inside of the braces. If you use the braces, you put nothing inside. Or you use 0 with a slash. So in other words, there are no solutions to this equation. So the solution set is empty. Let's finish this up by solving number 76. Absolute value of 3x minus 2 plus 4 equals 4. So again, my task is to isolate the absolute value. It should be alone on one side of the equals before I try to rewrite the equation without absolute values. So I'm subtracting 4 from both sides of the equation. I wind up with absolute value of 3x minus 2 equals 0. So when this number is 0, then I simply drop the absolute value bars. When the number on the other side of the equation, when I have an absolute value and nothing else on the other side of the equation, 0 on the opposite side of the equation, the process to rewrite this without absolute value is to simply remove the absolute value bars. Notice that if this number was negative, we did not go any further. We knew that there would never be any solutions. If this number, once the absolute value is isolated on the other side of the equals, is positive, then we get two equations separated by the word or. So I go ahead and solve this by adding 2 to both sides. So 3x is 2. And dividing both sides of the equation by 3. So in this case, my solution set is the set which contains 2/3. And that's my solution.